Hi guys, today I'm gonna give another part two of like harder rational equations that you guys might have to do. So if I have something like y is equal to 3 over x squared plus 1. I know I can look at this and see that the denominator is going to be greater than the degree of the numerator. So I know that my EBA is y is equal to 1. So I think about my vertical asymptote, my in behavior asymptote. The in behavior asymptote for this, the vertical asymptote for this does not exist because it's impossible for the denominator to equal 0. The EBA is, since the denominator is bigger, will be y is equal to 0. So when I'm thinking about how this is going to be put together, then I know that I know that y equals 0 is going to be my horizontal asymptote. And you remember from the first video, it is possible for us to be able to cross an asymptote. There is no x-intercept, but there is a y-intercept for this problem. And the y-intercept would be 3. So the y-intercept is going to be 0, 3. So that's going to be up here. And if I kind of want to know what's happening with this problem, I might have to do a t-chart on this one. So if I say, if I'm looking at this and I have x is equal to -1, I get 3 over -1, which is going to be, no, it's going to give me 3 over 2. If I have +1, that is also going to give me 3 over 2. If I have -2, that's going to give me 3 over 5. And if I have +2, it also gives me 3 over 5. So when I look at that, I get 1.5. This is going to be symmetrical. If I have 2, it's going to be down here. So what happens in this equation is this graph is going to come up and it's going to come back down. So I'm going to get a graph that is going to look something like that. All right, what if I have something like y is equal to x plus 3 over x minus 1 times x minus 2 squared times x plus 1. The degree of the top is bigger than the degree of the bottom. Vertical asymptote is going to be at, horizontal asymptote is going to be at 0 again. So vertical asymptote, and I've got the EBA would be at y is equal to 0. The x-intercepts this time, there are 2 of them, at -3, 0, and at 1, 0. And then the vertical asymptote is going to be at x is equal to 2 and x is equal to -1. Y-intercept, you're going to fill in, so -3 over 4. So if I start thinking about the information that I have for this, so that I know at 2, there's a vertical asymptote. -1 is a vertical asymptote. 0 is a horizontal asymptote. And there is an x-intercept at -3, 0. And at 1, 0. And there is a y-intercept at 0, -3/4. The intersect, the middle piece of this is the easiest one for us to draw at the moment here. And that would be because I know there is no intercept between -1 and 2. So I know that this graph has to look like a parabola. So I'm going to get something that looks like this. All right, the next part of it, think about the behavior of your graph. All right, at 2, this is a squared graph, so it should make a squared behavior on the problem. So if you were to think about that, since this is going down over here, this piece would be matching it over here. So you would have something that looks like that. When I'm looking at the one over here, this is a single one, so down, up, and I would have a graph then that looks like this. So think about the behaviors that your graph would take whenever you're doing something like that. Kind of like, what you would want to work with that. So I hope that helps a little bit on some of the harder graphs that you might have to do with this.